Welcome to video number 5.2. We're going to look at balancing equations, why we need to balance them, and 5 types of reactions. So make sure you read chapters 6 and 7 of the book. Alright, so 5 main types of chemical reactions that you're going to have to know. Synthesis, decomp, single replacement, double replacement, and combustion. So let's do them one by one. Synthesis is another word for combination. And it is exactly what it sounds like. It's where two elements combine to make one compound. So you can have element A and element B, and you make compound AB. Look, it's element sodium, and it's element chlorine, and they make sodium chloride. Now you might be saying to yourself, what happened to the two? Well, when they combine, sodium's a +1 and chloride's a -1, so they get NaCl. Why is there a 2 here? Because chlorine is one of the 7 diatomics. It's the cool in the Nafkulbri. Alright, so when it's an element, it's got a 2. When it's in a compound, it cancels charge. H2 plus O2 gives you H2O. So some other examples I came up with are kangaroo plus a mango definitely gives you a mangaroo. A turtle plus a cantaloupe gives you a turtleope, of course. Okay, it's just synthesis. It's two things combined to make one. What's decomposition? Just what it sounds like. One compound is going to decompose into smaller compounds and elements. We're only going to have to predict compounds breaking into elements. But you should recognize that when there's one reactant, it's going to break down into 2 or more products. And it breaks down into its elements. So NH3 is going to break down into N2 and H2. CO2 is going to break down into C and O2. So why is there an O2 there? Because remember that carbon is not in Nafkulbri, right? So when carbon's by itself, it doesn't have a subscript, but when oxygen is by itself, it does. Okay, oh, look at the pumpkins decomposing, breaking down. Okay, here's some samples. Nitrogen dioxide decomposes. Well, it's obviously decomp because one compound, NO2, decomposes into its elements. Calcium reacts with oxygen. Calcium's an element, oxygen's an element, so that's 2 elements. This must be a combination reaction. If you see the formulas, only one reactant on the left-hand side of the arrow, that's going to be a decomp because what can one thing do? It can break down into small things. Element and element is going to be a combination. So you can recognize and classify reactions. Hey, there's 2 more we're going to talk about right now. Single replacement is first. So single replacement is soap opera chemistry at its best. My date left me for somebody better is what single replacement reactants might say. Because you got an element that's a single thing with a compound that's 2 elements at least chemically combined. What happens is that a new compound forms because the element kicks part of the compound out to make a new compound. And then the one of the elements in the compound gets kicked out by itself. Okay, so you have to use an activity series for this. Don't talk about that. And the most active substance gets to replace. So in this, an active metal can only replace a metal in a compound. So metals can only replace the front part of the compound. Non-metals can only replace the back part of the compound. So if this is your metal, then it can only kick out the metal part of the compound, which is the cation. And so look, it got kicked out. All right. If this is a non-metal, it can only kick out the non-metal or anion part of the compound. So look, the anion gets kicked out. All right. Here's a little soap opera, or well, I guess real life soap opera. So we have an element and a compound, and then Angelina getting kicked out, Jen, but we all know what happens in the end of that one. Okay, double replacement, just what it sounds like. 2 things in a replacement. This was single replacement, so it's an element and a compound. Double replacement is going to be 2 compounds. All right, and in this one, the you got partners and you got other partners, and then you change partners, but everybody still has a partner. You have to look at the formulas of the compounds. So partners A and B, notice A still is in the front of a compound because once in front of a compound, you're always in front. And so B and D did the switcheroo. All right, so A is still in front of a compound, but now it's with D. C is still in front, but now it's with B. Reactants are aqueous in this one, and we're going to look for solid products or precipitates or water or gas. Kind of like The old square dance. Woo. Okay, so here's some samples. How do we know what type of reaction is? Well, we have a metal, which is an element, and a compound. So this is going to be a single replacement. How about here? Well, we get to see the whole reaction. Here we have a compound and a compound. And look, sodium's still in front, but now it's with nitrate. Lead's still in front, but now it's with chloride. So this is a double replacement. Compound and compound is going to be a double replacement. Oh no, it's words, but words could tell us a lot because this is potassium iodide. That's a compound, K plus I minus, reacts with fluorine gas, so F. Oh, it's one of our diatomics. So we have an element and a compound, so this is a single replacement. Okay. Recognize the types of reactions. Combustion is the last type of reaction that we're going to look at. And for combustion, we're going to use oxygen as our fuel and hydrocarbon also. Okay, so in combustion, we have to have oxygen gas to make it burn and a hydrocarbon. So what's a hydrocarbon? Compound with carbon and hydrogen. Oxygen can be involved, but it doesn't have to as part of the compound. But oxygen does have to be involved as the other reactant. So we have to have two reactants. The products for this are always going to be carbon dioxide and water. That's not your lab you're burning, is it? Cut it out, peeps. Okay, so here's some samples. Methane burns. All right, so this is a hydrocarbon. You recognize that, hopefully. Hydrocarbon is a compound with carbon and hydrogen. And so it's going to burn, so it's going to use O2. So this is combustion. What can we recognize when we see a reaction? Look, hydrocarbon and oxygen is going to be combustion. All right. And look at this, carbon dioxide and water. Okay, sugar burns. So this is going to be, oxygen's going to make it burn. And here is the hydrocarbon. This time we have oxygen here, but even though oxygen's part of the hydrocarbon, we have to have the oxygen gas to make it burn. So this is also combustion. Hey, you're probably doing that right now inside your body. Woo! Okay. So even if you don't know what the products are, so we're going to be predicting those, you should be able to recognize the 5 types of reaction. So combination, you're looking for 2 elements. Decomposition, 1 reactant. Single replacement, an element and a compound. Double replacement, 2 compounds. And combustion, hydrocarbon and oxygen. Whoa, look at this. Okay, so we've got an element here and an element there. Those are 2 elements. This is going to be a synthesis reaction because the only thing they could do is come together. Compound, 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 compound. Let's see what a compound is. Double replacement. Okay, hydrocarbon. So we have an element, it's a compound with hydrogen and carbon, and the element oxygen. Now you might be saying compound and element, that's single replacement. But if the compound's a hydrocarbon, the element's oxygen, is combustion. This is one big compound. What's it going to do? It's going to decompose. This is an element in a compound. What's going to happen there? Single replacement. Okay. So to review, here's maybe a summary that you could put in your notes that might help. You should be able to look at a whole reaction and tell what type it is, or just the reactants and tell what type it is. After you know what type it is, you're going to have to be able to balance them and predict products. Why do we balance equations? We balance equations because there's a law. And this happens over and over, that what goes in mass-wise must come out mass-wise. You can't lose or gain. No mass is lost. No mass lost. Okay, it's conserved. It's conserved, right? So that means if you have 5 hydrogen atoms going into a reaction, you better have those same 5 coming out. They might be in new bonds, but they must be accounted for. Here's a visual of it. It's like a seesaw, right? We have a purple element and a green element going in. So molecule and an atom to form equaling a new compound. But you still have 1 purple, 2 greens, 2 greens. This is balanced because the mass is equal on both sides. Now it makes a new substance, but it's still all of the atoms are there. Okay, let's look at it again. This is C3, so here's your 3 C's. H8, so here's your 8 H's. Do we have that on the other side? Well, here's our 3 C's, which is indicated by that, and 8 hydrogen, which is indicated by that 4 times 2. Oxygen, 10 oxygen, 5 times 2 is 10 oxygen. Oxygen on this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygen. Let's see, 3 times 2 is 6, plus 4 is 10. Plus 4 is 10. So all atoms are accounted for. That's a balanced equation. Subscripts tell you how many atoms are in the of that element are in a particular substance. So C2, 2 C's, H6, 1, 2, 3, 4, 5. 6. So subscripts show you what's all bonded together. Right? And that's part of what the identity of the substance is. So subscripts are part of the identity. So let's look at how many atoms are here. Here's a compound, carbon dioxide. How many carbon atoms? 1. How many oxygen atoms? 2. How many nitrogen? This is ammonium carbonate. There's a nitrogen right there, but there's 2 on the outside multiply. So there's 2 nitrogen atoms, 8 hydrogen atoms, a carbon, and 3 oxygen. Here's 1 potassium atom, 1 manganese atom, and 4 oxygen atoms. So you should be able to count how many of each kind of atom are in compounds. What's a coefficient? Coefficient is a multiplier that's in front of a compound. So anytime you have a coefficient, it means that many times of what's behind it. So this means 2 HCl's. So that's what this 2 means. There's 1, 2 for 2 HCl's, right? And there's coefficients of 1 if you don't see them, all right? The coefficients of 1 are implied. So now we got to use coefficients to try to count. So carbon dioxide is CO2. If we have 2 of them, there's 1, there's 2. So you multiply 2 C's and 4 O's. All right. If you need to write it out, write it out. Okay. So 3 ammonium carbonates. So we have 3. So there's 2 nitrogens in the compound. So 2 times 3 is 6 nitrogen atoms. There's 8 hydrogens in the compound. 8 times 3 is 24. Wow, that's a lot of hydrogen atoms. There's 1 carbon in the compound. So 3 times 1 is 3 carbon atoms with the coefficient. And 3 times 3 is 9 oxygen. Here we have 6 potassiums now, 6 manganese atoms now, and 24 oxygen atoms. So coefficients are multipliers. What does the 6 mean? It means, I picked this one right? 1. So that's 3 of them, 4 of them, 5 of them, and 6 of them. So the coefficient means a multiplier. So instead of writing 6, now I have 1, 2, 3, 4, 5, 6. But if you don't see all those, wait, gone now, that's what this 6 means. 6 times that compound. Okay, so let's balance these equations. First, let's look to count. We have 2 H's on the left, 2 H's on the right. 2 oxygen atoms in the reactants, 1 oxygen atom in the product. So we need more oxygen in the product side. So I'm going to put a coefficient of 2. Always start with low coefficients. Now I have 2 oxygen over here and 4 hydrogen. So I need to go back to my reactant side and make sure I have enough hydrogen. So I put a 2 there. So now I have 4 H's, 2 O's, 4 H's, 2 O's, balance. Woohoo! Yeah. Okay. And 2 N's, 2 H's, 1 N, 3 H's, not balanced. So let's look at how to balance it. I need 2 N's on this side. So I put a 2 there. Now I have 2 N's on that side, 2 N's on each side. So that 2 changes my H's to 6. So 6 hydrogen on this side. I need 6 hydrogen on that side. 3 times 2 is 6. Now it's balanced, and you could always check your work. Yeah, as long as you can count and multiply, you guys rock it. You win. Okay. So here's what we noticed. We noticed that we can balance formula equations. We also, by using coefficients. Yay, coefficients. Woo! That's how you balance an equation. And then we balance equations because of the law of conservation of mass. And then there are 5 types of reactions to know. Okay?